basic idea of integration by parts is that it lets you differentiate part of the integrand, but only if you're willing to pay a price. And that price is anti-differentiating the other part of the integrand. Well, let's try it. For example, let's find an antiderivative of x times e to the x. If we're going to attack this integral by parts, then I've got to pick a u and a dv. I'd be willing to differentiate x. That'll make x just go away. And the price I'd have to pay is to anti-differentiate what remains. But anti-differentiating e to the x is not much of a price to pay because e to the x is its own antiderivative. So let's set that down. Let's set u to be x, since I'd like to differentiate that part. And I'm willing to anti-differentiate what remains. Now let's figure out du and v. Now if u is x, then du is dx. And then I've got to pick an antiderivative for dv. Now, in principle, there's a ton of antiderivatives I could pick, right? E to the x plus 17 differentiates to e to the x. But I'll just pick the nice one. I'll pick e to the x. Now I've got u, dv, v, and du. We can put it all together. Parts tells me that an antiderivative of u dv is uv minus antiderivative v du. So in this case, the antiderivative of u dv is u times v, x times e to the x, minus antiderivative of v du, which is just dx. But I know how to integrate e to the x. Antiderivative of e to the x is just itself, so the antiderivative of x e to the x is x e to the x minus e to the x plus some constant. We did it! And we can check our answer. So I just have to differentiate this and make sure I get x e to the x. Let's try it. So if I differentiate x e to the x minus e to the x, I don't need to add the plus c, because if I differentiate a constant, I just get 0. All right, this is a derivative of a difference, so it's the difference of the derivatives. But now this is a derivative of a product, so I'm going to use the product rule. I'm going to take the derivative of the first, so the derivative of x, times the second, plus the first times the derivative of a second. All right, that's the product rule. And then I subtract, well, the derivative of e to the x is just itself. And now I've got the derivative of x, which is 1 times e to the x, plus x times the derivative of e to the x is e to the x, minus e to the x. And here's the slightly exciting part, right? This and this cancel. And all I'm left with is just x times e to the x. So in fact, we have found an antiderivative for x e to the x. Here it is. And of course that makes sense, because integration by parts is just the product rule in reverse. Now we can use the same trick to attack similar integration problems. For example, let's say you want to anti-differentiate some polynomial in x times e to the x. You could do this with parts. Well, how? Well, I'd make this be u, and I'd make this be dv. And why is that such a great choice? Well, think about what parts lets you do. Parts lets you differentiate part of the integrand if you're willing to anti-differentiate the rest. But anti-differentiating e to the x is paying no price at all, because it's its own antiderivative. And if you differentiate the polynomial, then you reduce its degree. So by doing parts enough times, eventually you're just anti-differentiating e to the x by itself, which you can definitely do.